Good evening, boys and girls. Welcome to another lesson on Technical Sciences Grade 12. It is the 29th of October. It is a Thursday, and I hope that you are revising. And I hope amongst those subjects, you have Technical Sciences as part of your daily study plan, because I want you to do well in this particular subject. Now, we are continuing with electrochemistry, and we are going to look at the last section of what you are required to know in this particular topic, and that is a section on alternative energies, or sometimes it is just called alternate energies. So we are going to interrogate that for the better part of the lesson for today, but we'll also be looking at questions, but we will get to that when we look at the structure of the lesson. I hope that you have your pens ready as well as your paper or your notebook so that you are able to take down notes which will help you in revising and understanding this section of the work much better, and so that you have something that you can always refer to when you are studying and you are preparing for your final examination. Remember once more, my learners, that electrochemistry forms part of paper 2. It's quite a lengthy topic, not difficult at all, actually quite easy and interesting, and very much practical as well. And hence, we like introducing these types of topics to you. So let us get into the structure of the lesson for today. We will look at electrochemistry as per the examination guidelines, but we'll just check one aspect, which is an aspect on alternative sources of energy, and check what actually are we required to know as per the examination guidelines. And in features of the topic, we will definitely be learning electrochemistry, and we will be learning the alternative sources of energy. And we will do questions on electrochemistry. Amongst those questions will be a question that tests if we've really understood the lesson for today on alternative energies. And then we will go into examination type of questions and look at a question that is really of a good standard from a given examination in the past, so that you see how these questions are asked. So from today and tomorrow, as well as Saturday, we will be dealing with a lot of questions so that we are able to cement our knowledge, and we can answer the type of questions that are asked. And then I will be giving you more tips in terms of exam preparation for the section that we have dealt with, and remind you of the mark allocation for this particular topic. Right, so we have talked about the following definitions that we have to know, and that is the definition for oxidation, for reduction, a definition of an oxidizing agent, a definition of a reducing agent, the definition of electrolysis as a chemical process, the definition of what a cathode is, and the definition of the anode. I hope you remember that, my dear learners. We are also required to be able to write down oxidation half reactions, reduction half reactions, and the overall cell reaction altogether. And this applies to both galvanic cells as well as electrolytic cells. And we have discussed the latter quite extensively. And we must be able to assign the oxidation numbers and the rules that we apply in assigning oxidation numbers altogether. And most of the questions that we will do tomorrow as well, they will be questions that really help us in assigning oxidation numbers. So we'll definitely learn more tomorrow with regards to that. And then remember, we are also required to be able to define what an electrolytic cell is, and also be able to define what a galvanic cell is, and also be able to define the term electrolyte. Now, I'm not doing that for now, my dear learners. We've done this and we've discussed this. Then we must know the processes in electrolytic cells, as well as the redox reactions that take place in electrolytic cells. So with that, we must be able to describe the movement of ions in the solution. That is the ions from the electrolyte, the ions that are moving towards the cathode and the anode, the ions that move from the electrode into the electrolyte solution when electrons are lost. So we need to be able to track the ions. We must be able to state the direction of electron flow in the external circuit. That's where we are able to tell them that electrons actually move from the anode to the cathode via the external circuit. And we must be able to write down the half reactions at the anode as well as at the cathode. And you will remember, my dear learners, that at the anode, that is where you have oxidation. And at the cathode, that is where you have reduction. So at the anode, you would then write the oxidation half reaction. And at the cathode, you would then write the reduction half reaction. And also being able to write down the overall cell reaction altogether. And we must be able to use half reactions to explain how copper 2 chloride excuse me, is decomposed. In other words, the electrolysis of copper chloride aqueous solution. And then we must know the components of a galvanic cell, and amongst those, we need to be able to state their functions, every component in a galvanic cell. Furthermore, we must still be able to describe the movement of ions in the solution, that is in both of the half cells, and then again, still be able to state the direction of electron flow in the external circuit. Again, we must be able to write down half reactions that occur at the electrodes, that is the anode and the cathode. And then we must be able to state the functions of the salt bridge. And remember, we have 2 of those, right? I hope you still remember that. Then we must be able to write down the standard cell notation so that we are able to use it to represent a galvanic cell. Remember, my dear learners, the standard cell notation is a short version of representing a galvanic cell. So if I give you a cell notation, you must be able to take that and interpret the half reactions that are taking place. You must still be able to take a standard cell notation and represent it as a schematic galvanic cell. Furthermore, you must be able to take a galvanic cell and be able to write down the half reactions and be able to take it into a standard cell notation altogether. And you will recall how we write a standard cell notation. We are not dealing with that for now. Just reminding you of the things that you should be knowing at the moment. And then we must be able to write down still the overall cell reaction, and we know we do that by combining the two half reactions. In other words, combining the oxidation half reaction as well as the reduction half reaction. And then we must be able to use table 4B, right? Which is a table of standard reduction potentials to calculate the EMF of a standard galvanic cell. And remember what I said about the EMF. Sometimes we can simply say the cell potential, or we could simply say the potential difference altogether. So that is of a standard galvanic cell. In other words, a galvanic cell that is operating under standard conditions altogether. And then we note again that if we have a positive value of the standard EMF, then it tells us that the reactions are spontaneous reactions. And the reason is that the value of the EMF is a positive value. And we must be able to determine the electrode potential of a copper zinc galvanic cell. And then under standard conditions, we must be able to write down standard conditions under which standard electrode potentials are determined. So those values on table 4B, we need to know the standard conditions under which the cell would be operating so that those reduction potentials are calculated. And we know we have 3 of those standard conditions, and only one of those is true for gases, which is a pressure of 10.13 kilopascals. Right. Now, this is where we are focusing today. Alternate energies, right? Which are alternative sources of energy, which means other sources of energy altogether, other things or other processes that can give us energy. And we are going to look at biodiesel. 1, we are going to look at the fuel cell. 2, and we are going to look at a photovoltaic cell, which is 3. So for these, we must be able to discuss the use of alternate energies and their environmental impact. So we must know the uses of biodiesel, the uses of fuel cells, and the uses of photovoltaic cells. And there we will learn what they are, what their uses are, which are basically more of the advantages, and also their environmental impact, of which some of them are negative impacts and the disadvantages. So in a nutshell, my dear learners, we will first learn what that source of alternative energy is, and we'll look at the advantages of using each of those alternative sources of energy, and also the disadvantages of those alternative sources of energy. Right, we get to the main content of the lesson. Alternate energies, alternative sources of energy. So a question could arise, my dear learners, and say, list 3 forms of alternative sources of energy that you know. and we are going to learn these ones. So you will say, okay, another form of energy is biodiesel. Another form of alternative energy are fuel cells. And another form of alternative energy, those are photovoltaic cells. So these are three alternative sources of energy that we can use to perform various processes, to operate machines, whatever that you can think of. The three alternative sources of energy, it's your biodiesel, your fuel cells, as well as your photovoltaic cells. Right. Now, let us start with biodiesel. Now, just that bio there, the prefix, tells us something about life, or it tells us something about living things altogether. Right. So, what are we talking about when we talk about biodiesel? Now, biodiesel in itself is a fuel altogether. Like we know diesel to be fuel, the petroleum diesel, we are used to petroleum diesel, and we know that is fuel. So this time we are not talking about petroleum diesel, we are talking about biodiesel. So it is still a fuel. It is just that it's an alternative fuel. And biodiesel is produced from vegetable oils, animal oils and fats, as well as waste cooking oil. That is why, my dear learners, it's not just diesel, it's biodiesel, because we actually use living things, right, to make biodiesel. So we use vegetables, which are your plants. We use animals, which are your plants. But in particular, we extract vegetable oil, animal oils and fats, as well as waste cooking oil, like the oil that we use at home, the wasted oil. It is then used and a mixture is made, and that is going to give us biodiesel. And obviously, with all these vegetable oils and animal fats and waste cooking oil, a process of purification must be there so that this biodiesel is efficient and it can work altogether. For example, there are locomotives, which are trains that use biodiesel altogether instead of electricity or instead of petroleum diesel. So biodiesel is definitely made from vegetable oil, animal oils and fats, as well as waste cooking oil. Now, what are the advantages of biodiesel? Now, the fact that biodiesel is made of plants and animal fats, it tells us that it is not toxic. Now, my dear learners, please, when you give us advantages, you need to explain, because we need to understand why are you saying that is an advantage altogether. So you say, okay, it is made from plants and animal fats altogether. Thus, it is not toxic. Then you will get 1 mark. And those are the things that you must remember. Now, biodiesel, we know that it can be used by locomotives and other forms of engines. So the exhaust will still give emissions, but those emissions are going to be lower. So you will have lower exhaust emissions. So the gases that come from the exhaust, they are lower as compared to when you are using a normal petroleum diesel altogether. And that means pollution is reduced. And the critical weight there, my dear learners, is that the exhaust emissions are lower. It's not completely zero. We still have exhaust emissions, but they are lower and therefore pollution is reduced. Then again, we have lower carbon dioxide emissions altogether. So they are lower. It's not a matter of biodiesel is pure and it doesn't give any emissions. It still gives emissions, but they are lower. The exhaust emissions are lower. The carbon dioxide emissions are lower. And we know that when we have lower carbon dioxide emission, it means we have reduced the impact on global warming, because carbon dioxide accelerates global warming. So if you have a lower carbon dioxide emission, it means you have reduced the impact on global warming. So how do we remember this? We say, okay, the advantages are the fact that it is made up of plants and animal fats and oils, so it is less toxic. And the fact that it's still biodiesel, there are still emissions, but the exhaust emissions are lower, and therefore pollution is reduced. And the carbon dioxide emissions are lower, meaning there is a reduction in the impact of global warming. Now, what are the disadvantages of biodiesel? Now, you will remember that I said it is also made from waste cooking oil. Now, if biodiesel is manufactured from cooking and waste oil, then you will understand that it becomes challenging to purify, to make it clean, because it contains contaminants such as meat and food scraps. For example, my dear learners, your waste cooking oil, it's not as clean as before you have used it. So after using it, there are food scraps in there, there are meat scraps, there are things in there, and therefore it has to be purified. So those things, those objects that we get in our waste oil, we refer to them as contaminants. And therefore, they must be removed before the oil is converted to biodiesel altogether. So you remember that, oh, because it can be made from waste cooking oil, then it will then become challenging to purify it, because there will be contaminants, because it's waste oil. There'll be things like food scraps, meat scraps, and so on. And those have to be removed first before the waste cooking oil or the waste oil is converted to biodiesel. So that would be a mark. Again, my dear learners, biodiesel relies on good harvest of plant matter. So if you don't have a lot of plants, so you don't have a good harvest, so you can't get enough plant oil, so you will get less biodiesel. So it simply relies on good harvest of plants. If we don't have a good harvest of plants, then we can't manufacture enough biodiesel. Right, then we go to photovoltaic cells. Now, photovoltaic cells, my dear learners, you are probably used to them. Those are the cells, or rather, when we talk about solar panels, the solar panels that you see in some houses, and in those houses, they actually use those solar panels which absorb the energy from the sun, and that energy is then converted into electrical energy, and the electrical energy can be used especially for the geysers, for plugs in the houses, and so on. You will recall that most of the people now, or rather a lot of people, especially in suburban areas, they are starting to use them. And most of the time, you will see them on top of a roof altogether. Those solar panels that you see around, usually they are black, and from a distance they are a bit purple because of the reflection of light and so on, but those are photovoltaic cells. So we say photovoltaic cells are solar cells, and this photovoltaic cell, they convert solar energy to electrical energy. So remember that it's very important for you to know that, because these solar panels, they absorb the energy from the sun altogether. So the energy from the sun, we call it solar energy, and they convert that to electrical energy. And that electrical energy can be used at home for various appliances. Now, what are the advantages of these photovoltaic cells? Now, the mere fact that they simply absorb solar energy to electrical energy, it tells us that there is no harmful air that is released into the environment. They do not release any harmful air into the environment. All they do is they absorb the solar energy from the sun and they convert it to electrical energy. So it's not even a lower release. They just do not release any harmful air to the environment. That is a massive advantage altogether. And again, these solar panels, they operate reliably. They work reliably for a long period of time, and they do not require any maintenance altogether, with virtually no maintenance altogether, or with very little maintenance after a very long time. So they can work for years without any maintenance that is required. So they are reliable altogether, in that they can operate for long periods altogether. And then what are the disadvantages of the photovoltaic cells? So what are the negative impacts? Now, remember, they absorb the energy from the sun, which is solar energy. Now, the solar energy, the amount of solar energy that is absorbed by these photovoltaic cells, right, by these solar cells, by these solar panels, they determine the amount of electrical energy that you're going to have. So if there's very little sun today, maybe it's cloudy, then there's very little solar energy absorbed, and therefore very little conversion to electrical energy that will take place. So that is a disadvantage, especially on a cloudy day, because you will get less electrical energy. And that is why there I indicate that it is dependent on the sun, and cloud cover is not always predictable. So on cloudy days, there's little solar energy absorbed, and therefore less electrical energy conversion. But as well, it is expensive to manufacture. It is expensive to manufacture. Even if you want to buy it and have it installed, it is expensive. But after you have installed it, then you will pay a very small electrical bill altogether, right? Then the last source of alternative energy that we are looking at is fuel cells. Now, a fuel cell, firstly, it is a galvanic cell. Now, for the mere fact that I say it's a galvanic cell, you already know that it converts chemical energy to electrical energy. Altogether, it converts chemical energy to electrical energy. That is the first thing that I want to highlight to you. It is a galvanic cell. It converts chemical energy to electrical energy. Now, where does this energy, this chemical energy come from? It comes from a gaseous fuel altogether. It comes from a gaseous fuel, and then you get a chemical reaction of hydrogen with oxygen, and that will produce water. So in a fuel cell, remember, my dear learners, we can ask you, what is the product? You must know that the product is water. And then in a fuel cell, if we ask you, what are your reactants? What reacts? Then the learner is going to say, my reactants is hydrogen gas, and oxygen gas altogether. So the hydrogen gas is from the fuel, the oxygen is from the air, and then a chemical reaction takes place, and then we have a conversion from chemical energy to electrical energy. So that's how fuel cells work. There will be hydrogen gas from a gaseous fuel, a fuel that is made up of gas, and there will be oxygen gas, which is from air, and there will be a chemical reaction between this hydrogen gas and this oxygen gas, and that is going to produce water. And when that happens, you will have a conversion from chemical energy to electrical energy. And that is why we say a fuel cell is a galvanic cell that converts energy from a gaseous fuel to electrical energy through a chemical reaction of hydrogen from the fuel with oxygen from the air to produce water. Now, what are the advantages of fuel cells? Just like photovoltaic cells, they do not release any harmful air into the environment. Altogether, remember that they do not release any harmful air into the environment. Secondly, with fuel cells, you don't always have to use gaseous fuels a gaseous fuel that has hydrogen. You can actually use different fuels, right? Including that one with hydrogen or natural gas or methanol or ethanol or any biogas that you can think of. You can use it. It doesn't always have to be the hydrogen from a gaseous fuel. It can be hydrogen from a gaseous fuel. It can be any biogas. It can be any natural gas altogether. But the biggest one is that one that it does not release any harmful air into the environment. Now, what are the disadvantages of fuel cells, especially hydrogen fuel cells, right? The problem is actually with the hydrogen, because this hydrogen, the extraction of this hydrogen from the gaseous fuel is very expensive. Altogether, it is very expensive. And secondly, hydrogen is flammable altogether. And those are the alternative sources of energy that you had to know. So please remember that, and that is enough to take you through the exam, and somewhere, somehow, you must still be able to apply your knowledge in terms of these alternative forms of energy. So that is the main theory for today. And now we move to questions. Now, let us complete the following table, right? Biodiesel, we must give 2 advantages and give 2 disadvantages. Now, you must remember, my dear learners, I won't fill it in now for you. You will fill it on your own based on the notes that I have given you. And when you have done that, then you are going to have a summary that you can use to revise when you prepare for the examination. So all I'm going to do is just give you a reminder. Now, biodiesel, how do we remember the advantages? Remember that it is made up of plants, right? As well as animal oils, the plant oils and animal oils. And therefore, it is not toxic. So you will say it is made up of plants and animal oils, and that makes it not to be toxic, meaning not to be poisonous. Secondly, I said to you, biodiesel, if you compare it, for example, to petroleum diesel, biodiesel gives you lower exhaust emissions. So when you have lower exhaust emissions, it means you basically have pollution that will be less. So that is a reduction in pollution. And again, because of these lower exhaust emissions, it means lower carbon dioxide is emitted. And if lower carbon dioxide is emitted, my dear learners, it means there is less impact on global warming altogether. So those are the advantages of biodiesel. Now, what are the disadvantages of biodiesel? Remember, I said to you, biodiesel can also be made from waste oil or cooking oil. Now, if you have waste cooking oil, we know it contains contaminants, impurities, like your meat scraps that remain in the waste oil or your food scraps, and that makes it difficult to purify. So you will say it is difficult to purify if it is made from waste oil because of the contaminants such as meat scraps and other food scraps. Again, biodiesel, we said it is made up of plant oils. And therefore, for you to produce enough biodiesel, you must have a good harvest of plants. So the fact that it relies on a good harvest is a bit of a disadvantage, because if you don't have a good harvest, then you don't get sufficient biodiesel altogether. Then photovoltaic cells. What did I say about these ones? You'll remember photovoltaic cells are our solar panels, and they are made from solar cells. And all that photovoltaic cells will do is they absorb the solar energy from the sun and they convert it to electrical energy, which is quite a pure process, which does not release any harmful air or gases to the environment. So that is an advantage. It does not release harmful gases to the environment. And secondly, I told you, these photovoltaic cells, they can work for a long period of time with very little maintenance. So those are the two advantages. But what are the two disadvantages? Now, these ones, because they rely on the energy from the sun, on cloudy days, right? You could put it like this. On cloudy days, less solar energy is absorbed, and therefore little conversion to electrical energy. So on a cloudy day, you have less electrical energy conversion. So less solar energy converted to less electrical energy. And I also told you that it is expensive to manufacture. So those are the two disadvantages. Then we get to the fuel cells. And we need to talk about the advantages of a fuel cell. Now you will remember itself, it is a galvanic cell. So it converts chemical energy to electrical energy. Like in a hydrogen half cell, it uses a gaseous fuel that contains hydrogen, and the hydrogen gas reacts with the oxygen gas from the air, and we produce water. So the mere fact that we are producing water tells us that we do not release any harmful air to the environment because the product is water. So that is an advantage. So that is 1 mark. They do not release any harmful gases or air to the environment. And with fuel cells, I told you they are not limited to hydrogen. So this is how you actually give the second advantage, is that different forms of fuel can be used in fuel cells. And that will include hydrogen gas itself, your natural gases, your biogases, substances like ethanol, methanol, and so on. You can use those. But the disadvantages of these fuel cells, particularly your hydrogen fuel cell, is that this hydrogen is very expensive to extract. To get it, it's very expensive. So the extraction of hydrogen is expensive. That is one disadvantage. And another disadvantage is that it is flammable. The hydrogen gas is flammable. So remember all of that, put it, look at this lesson again, and then have that table, and you are well on your way to excelling in a question that will ask you on alternative sources of energy. Then we move to the next question. They tell us, Tina wants to investigate the effect of the area of the metal plates used as electrodes in a galvanic cell on the EMF of the cell. So Tina, basically what she wants to do, she wants to check the size of the electrode, right? The area of the electrode, if it affects the EMF of the cell. Now, my dear learners, we can actually answer this question from the NSET, and we'll say, no, it doesn't have any effect on the EMF of the cell. We know it theoretically. It's just that Tina now is going to experiment. Remember, the EMF of the cell is affected by the conditions under which the cell is operating. It is not affected by any other thing except the conditions under which the cell is operating. The 3 conditions that we talked about. Obviously, now the third one, which is a pressure of 101.3 kilopascals, applies to when I'm dealing with at least one half cell being a gaseous half cell. So we know already that there shouldn't be any effect because an area of the electrode doesn't fall under standard conditions. She set up the following zinc lead cell. So this learner is using zinc and lead cell under standard conditions. So this is now under standard conditions and measures the EMF. So it means these 2 electrodes, one will be zinc and the other one will be lead. We are not sure which one is zinc and which one is lead. So clearly we can see it's a galvanic cell. There are quite a lot of things that show us it's a galvanic cell. The 2 half reactions, we have 2 half cells that are separate. We have a cell bridge that connects the 2 half cells to complete the circuit and so on. So definitely it is a galvanic cell, and we've been told again that it is a galvanic cell. Then they tell us which electrode will show an increase in mass when this cell is functioning. When this cell is functioning. So we want to know the electrode. So the electrode will either be the zinc electrode or the lead electrode altogether. Now, my dear learners, you see from this question, the Z there, I honestly don't want to say to you that it was meant to be Z and the P was meant to be PB. It does not necessarily mean that altogether. So we must go and check our electrodes and check which one will experience an increase in mass. And obviously, the one that will experience an increase in mass is the one that undergoes reduction, right? Is the one that undergoes reduction. And that is definitely the electrode that is going to function as the cathode altogether. Because when a substance undergoes reduction, the ions gain electrons and they form a neutral metal atom. And by that, the mass of the electrode would then increase. So we go, and because we are dealing with a galvanic cell, we then need to check which substance between zinc and lead is undergoing reduction. Then check a different screen. There we go. There we go. Then we look for zinc. There it is. And we look for lead. There it is. So what did I say to you with table 4b? The one on top will undergo oxidation. Remember it like that. The one at the bottom will undergo reduction. And you know why it undergoes reduction? Because the reduction potential of lead is higher than the reduction potential of zinc. So lead loves reduction more than zinc. And I can see in the reduction form, Pb2 plus, when it gains 2 electrons with 1 arrow, it would form lead. And the lead would then form around the lead electrode altogether. And therefore, the one that underwent reduction is the one whose mass is going to increase. Right. There we go. So our answer there must be the PB electrode altogether. Right. Because they said Z and PB, I think any of these two will be correct. In fact, any of those will be correct. Then we must write down the equation for the half reaction occurring at the anode. You will remember our code, anox. Anox means oxidation occurs at the anode. Then we must go and check which substance is undergoing oxidation. So we have already learned that it is made, this galvanic cell is made up of zinc and lead. So if we want the half reaction at the anode, it means we want the oxidation half reaction because that is where oxidation takes place. And we talked about this. Anox means oxidation occurs at the anode. Then I have to go to my table 4b and just quickly double check. You see, we are dealing with zinc and lead. So the zinc is on top. It is the one that is undergoing oxidation. So it is the one that will lose electrons altogether. And if I want the oxidation half reaction, you know I will write from right to left. If I wanted reduction, I would have written from left to right. So in an oxidation form, I must write it in the form of right to left. So from right to left, this is what I'm going to do. I'm going to say, okay, zinc, single arrow, forms zinc 2 ions. plus 2 electrons. So I started with what is on the left and I ended with what is on the right. No, I started with what is on the right and ended with what is on the left. So I wrote it from right to left, and that is oxidation half reaction for 2 marks. And then we are required to calculate the EMF that we would expect Tina to read on the voltmeter. Now, they told us that it is operating under standard conditions. It means we can go and use the reduction potentials on table 4B. And I will somehow write it there. I will go to my formula sheet. I know that E naught cell is equal to E naught reduction. And I write the formula as it is, minus E naught oxidation. There we go, minus E naught oxidation. Then I'm going to get the first mark there altogether for the correct formula. E naught, E naught, E naught. This is for the cell, which is the EMF of the cell. E naught reduction, meaning the E naught value of the substance that undergoes reduction minus the E naught of the substance that undergoes oxidation. Then we go to table 4B. We check again. Lead is on at the bottom, so it undergoes oxidation. Zinc is at the top, it undergoes oxidation. We've talked about that. So the reduction potential of lead is negative 0.13, and that of zinc is negative 0.76. Then I'm going to say for the substance that underwent reduction, which is the lead, the E naught value was negative 0.13 minus E naught oxidation for zinc, it was negative 0.76. Then I do the mathematics. Negative 0.13 will still be negative 0.13. Negative times negative gives me positive, and that will be 0.76 altogether. Then you do your mathematics. What is 76 minus 13? That is definitely 63. So it will give me positive 0.63 volts altogether. So my dear learners, please, you have to be able to do this altogether. It's really not difficult. So the substance that underwent reduction was lead. I put in the reduction potential. That one for oxidation was zinc. I put in the reduction potential of zinc, and then I did the maths, and this is 1, 2, 3, and that will be 4 marks altogether. And this calculation we will ask you. Then name 2 variables that should be controlled during this investigation. Now, if you want that EMF, for example, to always remain the same, then you need to control the conditions altogether. It means the variables that must be controlled are the variables that must be kept constant, meaning they mustn't change, right? And that is temperature and the concentration of the electrolyte and the concentration of the electrolyte. Those have to be kept constant altogether, which are basically the standard conditions under which this cell was operating. Now, I want this to be clear. In fact, to write it correctly, it must be the room temperature and it must be the concentration of the electrolyte. You see, my dear learners, if you just write temperature, we're not sure what you're talking about, but when you say room temperature, then we understand, we give you a mark. When you just say concentration, it can be concentration of anything, but there you are clarifying that it must be the concentration of the electrolyte. Then you will get another mark. So that will give you 2 marks. Remember, a control variable, it's a variable that does not change. It has to be kept constant. Are we together? Right. Now, we are required to write down the cell notation for this cell. All together. Now, my dear learners, when we started here, we wrote the oxidation half reaction. Now, for us to be able to write the cell notation, we also need to know the reduction half reaction, even if they didn't ask us. And I want us to write it all together. Then we will be able to do the cell notation. Right? We agreed that lead is undergoing reduction. So reduction, remember, this table is a table of standard reduction potentials. So the reactions are already in a reduction form. So it means for reduction, I will write from left to right, but I will only use a single arrow. And that will then be for the reduction half reaction. From left to right, it will be Pb2 plus 2 electrons, and that is going to give me Pb. So if they wanted the reduction half reaction, this is what I would have written. But this is not what they asked me. They want the cell notation. Remember what I said about the cell notation? You'd start with what is happening in terms of oxidation. So in terms of oxidation, I go and I look at the oxidation half reaction, and I see that zinc was changed to zinc 2 plus. So Zn, a line of phase change to Zn 2 plus. And remember, the zinc was the electrode, so it will be solid. The zinc ions formed fall into the solution, so they will now form part of the aqueous solution. So I'm done with what happens in terms of oxidation. Then 2 parallel lines for the salt bridge. Then I talk about what happens in terms of reduction. And in terms of reduction, the lead 2 ions from the electrolyte, which was aqueous, have been reduced, so they change, a line of phase change to lead, which is a lead metal, and therefore it is solid. So 1 mark there for what happens in oxidation, 1 mark for the salt bridge, and 1 mark for the what happens during reduction. Altogether, 3 marks. Then Tina now replaces the 2 metal plates with ones of a larger surface area. So these metal plates, you will remember those are the electrodes. And now the electrodes are being increased in terms of size. So she uses electrodes with a larger surface area and takes the reading again. How would you expect the new EMF to compare with the one calculated in 1.3? So the EMF that I calculated there with a smaller surface area, basically, how can I compare it to the one with a larger surface area? And in fact, we want to know, how would you expect the new EMF? So I'm comparing the new EMF with the old EMF. How would I compare it? And my answer is that they will be equal altogether. Why? Because surface area, and that is question 1.6.2. Surface area does not affect the EMF of a cell. So the surface area does not affect the EMF of a galvanic cell. Altogether, it does not. That's why it will be the same. What would affect the EMF of the cell are changes to the factors that relate to standard conditions. So if I alter the electrolyte concentration, yes, the EMF would change. If I altered the room temperature, yes, the EMF would change. If I altered the pressure, if one of the half cells was, if at least one of the half cells was a gas, then the EMF would be changed altogether. Right. So that is all I had for you. Remember electrochemistry plus minus 43 marks. Go and learn everything. Draw, write, study, revise, and do it practically, and do a lot of questions from previous examination papers altogether. Plus minus 43 marks. I really want you to excel in this particular topic. So send me questions to stemdigitalschool@africateengigs.co.za so that I can help you tomorrow with the questions of your choice, and also on weekends during our question and answer session. Thank you so much. That is all I had for you. Enjoy the rest of the evening. Goodbye.